Hello class. Today I wanted to talk to you about two other ways that I've mentioned in your first video that science actually moves into technology which results in benefits to society. And I really enjoy these types of stories that come out of these two areas because you really don't think of how science works. The first area, and I want to go ahead and give you the two topics. They're biomimicry and serendipitous events. The first topic, biomimicry, what you need to do to get an understanding, I think, is to read the story of Velcro and how it came about. You can also read the unpublished manuscript I put on Blackboard that's about biomimicry and camouflage that I wrote for. It's actually an early grade level lesson which matches up with next generation science standards as far as how biomimicry can actually tie to science. Basically, a definition of biomimicry is where scientists and I think engineers study plants, animals, and other scientific events for uses. And a lot of biology, for example, is studying science for the sake of science, which is called basic science and not applied science. However, a lot of times things that you may think are basic actually eventually have a use. There is, for example, a famous scientist, Edward Wilson, who has spent a lot of his life studying ants. Well, you don't think ants have a practical use, but perhaps they do, based on some of his theories that he's developed. So, what I'm trying to say is that a lot of pure science actually does move into the applied science. Now, biomimicry is probably more purposeful in that through the observation of things in nature, be it plants or animals, scientists that have the wherewithal can a lot of times see practical uses. And it's not always scientists that make these observations. When you read the story of Velcro, the particular person that saw this use of this particular plant seed type, he wasn't a botanist. So the idea of biomimicry isn't just left up to the scientists. Anyway, I encourage you to read that short little article about Velcro and also the longer manuscript concerning an idea for biomimicry. I'll tell you a little bit about the article. Basically, I designed an activity, and it can be found on STEMwise, which I've shown you previously, the activity STEMwise on our website. I don't know if I have that. I think I still have that website written down somewhere. But anyway, the article talks about an activity that's based off an quite old activity of where a teacher used different colored toothpicks. And for example, she may have 100 green, 100 red, 100 blue, 100 yellow toothpicks. Go outside and just throw those toothpicks all over the school grounds and have the children spend, 10 to 20 seconds grabbing up as many toothpicks as they can. Well, if the teacher throws the toothpicks on grass, in theory, the fewest number that will be found will be the green toothpicks. And it usually works out that way. When the kids are searching for toothpicks, usually they don't see those, so it models camouflage. The activity that's described in the article I'm asking you to read, the unpublished manuscript, is also similar, but I changed it where it's a little bit more environmental friendly. It also doesn't involve going outside. Not that I'm against students going outside, but this is a little bit simpler way to do a similar activity. And basically it describes an activity where the teacher uses different colored construction paper, for example, green, red, blue construction paper, and she punches out multiple sets of colored dots so that when you dump the dots on this construction paper, for example, if you had 50 blue, 50 green, 50 yellow, 50 purple, and you put it on a green sheet of construction paper, more than likely the fewest number of dots that are going to be picked up is going to be the green dots, because the green dots match with the background. So I'd like for you to read that little article about that, and it talks about camouflage and how camouflage is a profitable business. So that, that's kind of the way biomimicry works. The other subject that we were talking about, by the way, here's the website, stemwise.edu, education.olemiss.edu. The other subject that we were talking about is serendipitous events. This one I think is just so interesting. You don't think of science progressing based on just random, and I won't say luck in some ways, I suppose, but just randomness, where perhaps the scientist is doing something with one thing, but they make this magnificent discovery that has nothing to do with what they're investigating. And a lot of times someone might say, well, you don't have to know a lot. Well, I think you do. Most cases when you read about these scientific serendipitous events, it's the scientist has the wherewithal to know that something may have value, even though it happened totally by accident. One example is the story of Velcro, and I've got that on Blackboard for you to read, so please read that, Story of Velcro. And another example that I always like to talk about is how the microwave oven got invented. It involved a scientist who was studying microwaves, and he wasn't looking to see how you make a microwave oven, but he just so happened to have a chocolate bar in his front shirt pocket that melted while he was doing scientific investigations with the microwaves. It sounds like it could have been harmful, but as far as I know, it didn't hurt him. But the chocolate bar actually melted in his front pocket, and he had the good sense to see a practical value for this as far as being able to cook things. I mean, who of us around here doesn't use a microwave oven? Most of us do, but there was a time where microwave ovens didn't exist. It's all based on shaking the water molecules in the different items. So basically, by him noticing that his chocolate bar in his front pocket had melted while he was doing these investigations with microwaves, it gave him the idea for the microwave oven, which again, like Velcro or Teflon, is a very profitable byproduct of this serendipitous event. Now, Velcro is not serendipitous; it's more biomimicry, but there are countless examples of where things just happen by accident for science to be of use. Now, you have two assignments that involve biomimicry and serendipitous events where you'll investigate and do a little description on these two things. But the bottom line is I think you'll enjoy looking these up. You can easily find a lot of these on the internet as far as how things have been modeled after nature, and also how things have just been totaled by luck, randomness. And this definitely ties into STS, and it ties into STEM, in that a lot of times these things discovered on a scientific level move into engineering and technology, and quite often mathematics is pulled into the equation. So that's all I have for this video. Thank you.